Hey guys, we are in unit four, I'm sorry, we're in unit nine, and we're going to be going into lesson two, which is chapter four. And in chapter four, we are looking at ecosystems. So, chapter four is all about ecosystems. First thing we have to think about is what are primary producers? How do consumers obtain energy and nutrients? How does energy flow through the ecosystem? How do ecological pyramids help analyze energy flow through ecosystems? How does matter flow between trophic levels and ecosystems? How does water cycle globally? What is the importance of the nutrient cycles? And how does nutrient availability affect primary productivity? So first things first, you've got your producers and consumers. This is pretty basic, kind of elementary level review. You know that your primary producers are your bottom level of your ecological pyramid, and they're all of the organisms that get their energy from the sun. Remember that all living things need energy. And as we learned in chapter four, energy from the sun is transferred through the process of photosynthesis and cellular respiration. The words autotrophs and primary producers are pretty interchangeable. They mean the same thing. They are referring to organisms that make their own energy from the sun, creating energy rich compounds that can be consumed by other organisms. When you think about producers, think about photosynthesis or chemosynthesis. Producers are organisms that make their own energy. The ones that we're most familiar with are the photosynthetic organisms, but organisms that undergo chemosynthesis, some types of bacteria that live kind of like at the bottom of the ocean near the sulfur vents, they use chemicals to produce their own food. Consumers and heterotrophs, just like producers and autotrophs, are two other words that are relatively interchangeable. They mean the same thing. So that means that they rely on other organisms for their nutrient and energy needs. Consumers are categorized by the way they obtain energy. We're familiar with some of these terms: herbivores, omnivores, and carnivores. Herbivores eat only plants, omnivores eat pretty much anything, and carnivores eat only other living things. In a food chain, we show the direction of energy flow in ecosystems. So the first rule of a food chain is that the arrow is pointing to the organism doing the eating. So in this food chain, the arrow is pointing to the owl, so the owl is eating the snake. The arrow is pointing to the snake, so the snake is eating the bluebird. So the arrow points to the thing doing the eating. Now we know that mushrooms don't like jump up and eat an owl, but what this is demonstrating is that when organisms die, the nutrients in their bodies are recycled back into the ecosystem by decomposers. And then once those nutrients are decomposed, they are then reabsorbed by producers, and the cycle continues. A food web is similar to a food chain, but a little bit different. In a food web, it shows the interconnected networks of feeding relationships. So you see how these organisms are all interconnected and rely on each other. What would happen in this food web if the rat population, if the frog was to become extinct? So I'm going to put you in a breakout room for a minute to think about what would happen to the rat if the frog became extinct. The next thing to think about is trophic levels. Ecological pyramids are models that show the amount of energy contained within each trophic level. The word troph refers to nutrition. So autotrophs, heterotrophs, that's referring to nutrition. A trophic level is the different nutrient levels. So you've got your producers, which is your first trophic level, primary consumers, secondary consumers, tertiary consumers, and then your quaternary consumers or apex predators. The 10% rule means that as energy is moving through the trophic levels, you're only left with 10% um, from the level before. So really for producers, when you move up to primary consumers, you're only giving 10% of that energy. For secondary consumers, they're only getting 10% of this energy. So energy depletes very quickly as it moves through the energy pyramid. Energy pyramids show the amount of energy contained within each trophic level. And this diagram shows that a little bit more accurately than the pyramid. You see the 10% rule at work. The letter J is referring to joules. It's the measurement, the unit of measure for energy. As we know from the law of conservation of energy, energy is neither created or destroyed. It's only transformed from one form to another. So these ecological pyramids are models that show the amount of energy that's present in each trophic level. Where does the energy go? It's important to remember that energy is measured in joules and it's neither created or destroyed. So we're just going to watch this quick video that explains how energy moves through the different trophic levels. Matter flows from one trophic level to another, and the elements are recycled within and among the ecosystems. So our biogeochemical cycles involve our atmosphere, hydrosphere, lithosphere, and biosphere. Biogeochemical cycles are the chemical interactions that exist between the between all of these different parts. Abiotic and biotic factors drive these cycles. You have your water cycle, which you are familiar with. The nutrient cycles, such as carbon, you've become familiar with in photosynthesis and cellular respiration from Unit 4. The nitrogen cycle moves atmospheric nitrogen among different organisms to make it the type of nitrogen that can be used for nitrogen fixation of plants. Your phosphorus cycle moves phosphorus around the ecosystem. And you can see that they're all related. We're going to stop here, and that's going to end the Unit 4 video for us. Chapter 4, Unit 9, Chapter 4.